Welcome everyone. I think it was 11. It is 11 now, and we can probably kick off this webinar. So welcome to this. Let me move that away. Welcome to the How to Detect Cars from Imageries using Deep Learning's webinars, and it's one of the webinar series that as Eagles will run periodically. So today I'm Edwards, and I'm local maps developers and machine learning leads here at Eagle Technologies. And we also have Ashley with us today, and she's the GIS solution engineers. And both of us works under the technical solution teams. And just a summary of the topics that we're going to talk about today, it will be the Geo AI. It's been a buzzword in the last couple of years or months, and we have got more success story now, and there's a lot of use cases that we want to share with you guys. And today we're going to focus on the how you can get started and why you need to get started. And one of the topics that we want to talk about more today is how to detect cars. And once you detect the cars, how you can do analysis and optional ways to visualize it. So yeah, that will be pretty cool. And at the end, we will also have a resources slides, so that if you guys want documentations, you can go. There will be a lot of links for it, and we will also have a Q&A sessions at the end to discuss ideas. In terms of asking question, you should find a question panels on the right-hand side of your screen to go to webinars. Feel free to ask question at any time throughout the webinars, and we will do our best to address this at the end of the webinars. So first, before we jump into the analysis and all the cool stuff, we want to kind of briefly talk about what's Geo AI. So basically, it's the location intelligence, the combination of location intelligence and artificial intelligence. So this is why we call it Geo AI, and it includes many aspects of machine learning and deep learning to solve highly complex or computationally intense problems. So take a closer look on what is AI. So it's really machine learning, and it's about extracting the patterns from data to derive rules. So instead of this rule being explicitly programs, and deep learning, it's just a type of machine learning using the deep neural networks to find complex patterns, especially in those unstructured data, image, text, voice, point clouds. And today we're going to, the data source that we use for today, it's array imageries, so which fall under the image categories. There's a lot of use cases and a lot of things you can do with AI, Geo AI's approach. So the classic way of doing things will be object detections, pixel classification, object classification, object trackings, and more. So we have, say, extract building footprints from satellite imageries, pipeline encroachment, finding a palm trees, tracking a truck in videos, and that's just some of the most common use cases. And of course, you can also do feature extraction from LiDARs to find to extract the power poles, extract the trees, real assets, and many more. And with that, we're going to move into the New Zealand, the pre-trained models that have New Zealand focus. So what it means is we got all these pre-trained models, and we want to fine-tune it with New Zealand localized data so that it can work with our data more accurately and more suitable for us for our workflow. So we have 4 at the moment. which we got, which we published in the last 12 months. The first one is the 3-point cloud classifications. Then we have car detection models, which is the main models that we want to talk about today. And we also have solar panel detection models and swimming pool detection models. And the improvement that we made with the car detection models, that's improved in the precisions. It got up to 89% now, and also the recall rates, which mean it will be able to detect at least 95% of the cars in your imagery. So, which is a pretty good numbers. And there's a lot more things that we make changes in the models, which can detect cars that got blocked by a light post, covered in shadows. We basically make it slightly more aggressive, so we can pick up all the cars for us. So take a glance on how it works. So you can once we have the area imageries, in this case the resolution in 7.5 centimeters, then you can use the models to run detections, and then it will just draw polygons for you and just label as this is a cars and what's the confidence levels. It can be partially covered in shadows, and it can also be fully covered in shadows. It will still be able to pick the cars up. So it's really good. It's a really good way for you to automate this process to find out the car distributions in the cities. So we've been hearing a lot that crashes have changed a lot in the last 5 years, and most of us know that, but it's really hard for us to quantify it. And today we're going to showcase how we can quantify the some changes in crash at CBDs, and the topic will be surrounding cars and transportations. And we have ran detections on a bigger scales, and we're just going to talk about the CBD areas today, so we can have more time to absorb and extract the informations and these specific areas. So, but what happens after you use the model to extract the feature to detect the objects from the area imageries? It's just a bunch of polygons, a lot of polygons, and you can't really extract too much information by just looking at all this polygon. Maybe there's some patterns that you can visualize, but to make it more prepared for us to do the analysis, we will need to filter it, we will need to classify it, so we can put it what sort of type, what's the status of the cars, and we have to do a lot of analysis to achieve this, and so that it won't be just the polygons, but it's something more meaningful. And with that, I'll pass it to Ashley, and she will show us some fancy dashboard and some really cool results.
Cool. Edward, are you able to change me? Yeah, there we go. Hi everyone. So yeah, so from our car polygons that we've detected, we can start to analyze and dive deeper into patterns and trends and start quantifying these changes. So I've done a quick analysis and quantified the car polygons for both the 2016 and 21 data sets. And as Edward mentioned, Christchurch has experienced a lot of change since the 2016 earthquakes. And so immediately post-quake, lots of empty buildings were used as car parking spaces. And then after the quake, the city has had to rebuild as a lot of damaged and unsafe buildings with a lot of damaged infrastructure as well. And more recently, in the last 5 years, a lot of new buildings and road infrastructure has been built in the city. And so with this comes a lot of new parking spaces on and off street across the whole city. And so this is why we've chosen to look between 2016 and 2021 as, yeah, there's a lot of change that's happened. And so to display my results, I've chucked it into a dashboard because everyone loves a dashboard. And so I'll zoom into a more central area in the CBD to show you guys what we've done. So here there's quite a bit of traffic due to this area being corporate, lots of corporate buildings nearby, as well as there's the hospital, Hagley Park, and museums, and yes, very central. And so currently displayed here are all of my car polygons. And what I've done is reclass them based on their car type. And so the pink cars are known as the active cars. So these are the cars that are considered to be driving at the time in the imagery. The blue cars are cars parked off street. Green are the ones on street, and then purple are the ones that are parked on roofs. And then on the right here of my dashboard, these are some indicators as well that kind of give the total count of the number of cars just in that little subset of our city. And you'll see as I filter through the car types, these will change to represent that. And so now I'll talk through each of the car types and how I classified them. And so this is all done in Pro using just a few tools. So first, active cars. These are the ones that are actively driving. And so we imported the Linz Roads layer from Living Atlas. And then using the select by location tools, we set a query where cars within a meter to a road line are considered to be actively driving. Since the road lines are center lines, and you've got, your left and right lanes, and sometimes multiple lanes on a road, setting a distance within the center line means cars close to this line can be considered to be on the road. And so here you can see in the 2016 imagery, there was about 130 cars actively driving, and then it increased to 164 in the 2021 cars. And I just want to mention that the time of imagery is about in the afternoon. So it's a time of day where there's still people coming into the city, people still in the city working, and yeah. And then the next category was off-street park cars. And so these cars are considered to be not on a roof, not on the street, and so they're further away from those road lines that we imported. For example, down in car parks or down driveways. And so also using the select by location tool as well as the select by attribute tool, we kind of find the inverse of the other categories. And so as you can see on the right, they're quite similar in terms of the number of cars parked off street between the 2 years. Moving on to on-street park cars. So these are cars that are still on the road, but they're most likely not moving as they're not as close to the road line. So we're assuming that these are cars parked on street, and in the CBD, this is expected as there's lots of small streets and parks outside of shops and facilities and buildings. And as we all know, you can pretty much park anywhere where there's no yellow line. And so from these indicators as well, again, the numbers are pretty similar between the 2 years. And then finally, roof parking. So this is where things get a little bit more interesting. So we detected building footprints by extracting the features from LiDAR. And so now we've got our detected objects, which are the cars and imagery, which we can merge them together to produce a more meaningful result. And so this was done using building and ground, and that's just a standard geoprocessing tool. And the building outlines, well, the building footprints are part of the results of the New Zealand 3D base map that Eagle is currently building. And so using the select by locations tool again, we set a query that cars that were completely within a building footprint classified as roof parking. As the 2 layers are layered on top of each other, you're kind of looking down from a top-down point of view. So cars on roofs are able to be detected. And this is the category that we've seen a significant increase from 2016 to 2017. So yeah, in AGO, I created some pie charts to really show the differences and car types between our 2016 and 2021 data sets. And so, as I mentioned, there's been a significant change in the number of cars detected on roofs, an increase of 5% from 2016. Now, having lived in Christchurch City myself during my studies, and Edward as well, we've seen the change in the city and how many parking buildings have been built, especially with roof parking. And so roof parking allows the utilisation of space, which is really important in a city. And some other benefits include that since it requires less space, it allows for more greenery to be built around the building on the ground. And then it also offers a safe way to separate vehicle traffic from passenger traffic. So this is something that's very important to consider when planning a city. And so with this data, we can also visualize it pretty quickly in 3D. And so I've added the cars and buildings and a building footprint of a rooftop building into a 3D scene. And so I've applied 3D symbology and offset the car layer, and this makes it look like they're sitting on top of the building. And so this is a cool way to replicate a rooftop car park. Cool. So to further look into the spread of the cars detected, we also ran some analysis tools in Pro. The first one was density-based clustering. And so this is to show the car density by identifying car park centroids. And so in the first picture here, there's a lot of grey dots, and this kind of represents a bit of noise. And so these are cars that don't fall into a cluster. And the second pic in the picture, you can see there's a lot less grey dots. And so this kind of gives an indication that the rebuild of the city has created more tidy and I would say uniform parking with more parking lots rather than just random off-street, on-street parks. And so we also saw this with our indicators where the number of cars for each car type still remained relatively similar between the 2 years, except for the change in roof parking. And so you can also use these results to trace car distribution change in the city. And so here's another site in town that has a lot of changes. So this kind of suggests that those areas on the left in 2016 where there's been a lot of clusters of car parks, it kind of suggests that maybe those have been removed and maybe in place of those are more buildings. Cool. So the last tool that we used was finding hotspots between the two maps. And so these are screenshots of results to allow us to see what's happening at a glance. Comparing the two hotspots, there's a lot of cars in the city, we can see. And so we've concluded that biking will probably be the best option. No, it will be a complicated model to estimate the time analysis, which this is for someone else to do. And our workflow has just prepared the data for you guys to use and perform more advanced analysis. And so that was just some of the analysis possible using some of the results of the car deep learning model. And we're very excited to see what you guys do with this model and all the other ones that are available in Living Atlas. And so I'll pass back to Edward now to tell you more about these models.
Okay, cool. Thank you, Ashley. And I think those results really good. It's showing what we can do after we use the deep learning models, detecting the objects and how it can generate the analysis ready content for us, so we can fit it to different use cases. But that's just kind of like one of the layers that we're showing, and you can have other layers as well. You can detect, you can extract trees, you can detect solar panels, you probably don't want to see a solar panels and cars sitting next to each other, so it's likely not going to happen, but we'll be interested if we can run all those models and put all the results into one place. But I guess some things that we want to focus today is also not just all the cool stuff, but also how to get started. So we have this authoritative package sitting in Living Atlas now, and you guys can just go to the Living Atlas and just search for DLPK, or you can search deep learning models. DLPK, just the file format, or short forms if you want to be faster. And you can search for New Zealand focus. So we can find 3-point classification, car detections, and the other models that I mentioned before. So instead of going to the browser to search it, you can also go to ArcGIS Pro and go to your portals, go to the ArcGIS Living Atlas, the Living Atlas panes, and you can just search it from there, and you will still be able to get the models from there. So why are we so passionate about it? Because we got a lot of good data coming in. There's a New Zealand elevation data programs which have LiDARs, and that the coverage in 2024 was expected to be at least 80%. So we also have a viewers to actually just look at what data is available, and you can see most of the cities have data that's available for you to do analysis already, and there's a lot that's coming soon, and there's also collection in progress. So this is definitely some things I should keep your eyes on if you haven't really got a chance to explore this. This data service, it's also a portals, a place for you to get your imageries to test out some of the workflows, and also this is the source that we get the Christchurch area imageries from for 2021 and also 2015 or 2016. So we can do the comparison between 5 years. So what we're trying to achieve, and also what you can achieve, is show you the way how you can where you can get the data, where you can get the models, which from LINS Data Service, from Living Atlas, and bring that to things together, and to get generate the results, which is all the polygons that you detected, or the features that got extracted, and you can, if you have imageries, if you fly drones, and you can use your own data as well, and you can do all this in ArcGIS Pro. Then you can publish it, all these contents, to ArcGIS Online to visualize, or to share it with your team to do more analysis, and you can of course share it to scene viewers or dashboards, just how Ashley did it. We also focus on a lot on how to get you guys started. We utilize story maps a lot, and we write a lot of story maps to help you install the deep learning frameworks or the essential libraries. And also we have story maps for each models that we publish, and you have the informations and a 2-minute video tutorials so that you can follow step by steps to get the models, run the detection tools, and get the results. And all these documents, it's written by GeoAI rookies, which is graduate or interns that first time experiencing the GeoAIs, and this is all the notes that they put in, and hopefully this will be giving you a really good insight how, and also understanding how you can get started. And also you don't necessarily need to download all of the models, because some of the models, most of the models are pretty small. Some might be like 500 megabytes, or there's one huge one which got released recently. It's the segment anything models. It's more than 2 gigabytes. So if you don't want to download it, you can actually just go search it and just drag and drop into the model definition, and it will just pull it straight away. That's how why we want to get you guys started to use GeoAI, how you can get started. And I guess I want to do some simple math to kind of show what's the benefit of using GeoAI. So let me put you into the scenarios where there's an intern, there's an intern Billy's, then he got a task that he need to find all the cars in the cities and do some comparisons, just like what we have done. And to find some cars, that's okay. But if we want to find a whole city, that's a lot of labeling and a lot of polygons drawings. Let's say that in the Billy enjoyed this process and it only takes 5 seconds to label one car. What if we want to do it in a bigger scale and we want to do it for multiple cities or a nationwide kind of like car layers comparisons? Just for that subset of cities, of Cratchit cities, we have already detected 22,000 of car polygons. And let's put it into this equation and say there's 22,000. We're just going to do it within the subsets, the size. We want to compare for 2 years, which is 2016, 2021, and each of the drawings polygon, the car polygon, take 5 seconds to draw, and we say we want to do it 4 times the scales, and we want to do it in 5 different cities. All of this combined together means Billy need to spend more than 1,000 hours just drawing polygons, and it also means that non-stop, no mistake. And what if we want him to repeat this process next month or next year or every year? So this is for scalabilities, and also in terms of the error rates, using a deep learning models might be a way to reduce the error rate, because the machine will just behave the same after 1,000 hours. It will still use the same models, same methods to detect the cause, and human get tired and might make mistakes. And also from the project management perspective as well, the cost that you have to put in to hire someone to draw these cars for the quality trackings, and this is why deep learning models could be an alternative way of doing things or planning your future projects. So we've seen a lot of like tools and workflow that we can do in ArcGIS Pro. There's also a new product called Deep Learning Studio, which allows you to do all this end-to-end deep learning workflow in a web browser. It's a web-based application that allows you to label your training data, train your models, run inferencing, and it can have like multiple users working together. So your whole team, your organizations can just work in one single place instead of sharing a project, send it back and forth, or using a VM. So you can, this is the 3 main actions. This is how the interface looks like. And it just fetch all the image straight from your image server. So you don't have to do a lot of image management. You just configure, because it's with enterprise and work along with your image server. And there's also a dashboard for you to review the labeling, the training chip. So once someone's do all the labelings to prepare the training data, you can also review it before you actually start using it. So you can make sure the quality is there. And at the end, you can pick what models you want to use, what's the inputs imagery source, and then you can start running the inferencing to get some result, which is the detected objects. So that's just the deep learning sort of workflows. In ArcGIS Pro, in Deep Learning Studio, the density-based clustering tools that Ashley have shown previously, it's actually a machine learning-based tools. And you can use it for cars. You can also use it for trees. This is just another workflow that we have created last year to do canopy monitoring in the cities. So you can, once we use the deep learning models to extract the tree points from LiDARs, then we can use this density-based clustering tools to get a cluster, which is a canopy in this case. And you can see there's a lot lesser noise, because most of the tree just sit together. It's not like cars. The cars will just be isolated somewhere. And what else we can do from here is we will get a lot of attributes, and we can put all that into one table. So you can get what's the trunk height, what's the tree heights, the where's the breast height, the canopy diameters, the point densities within the canopies, and all this will help you to monitor the tree health and also the canopy change in the cities. And actually also shown some of the 3D flavors with deep learning models results. So say that the cost, if you want to put it on top of a roof, if you have a BIM models and you want to put the detected polygons on top of it, you can do it in our scene viewer as well. And there's also other workflows that we can extract the roof and smooth it for you. So you can do analysis on roof and cars, what's the relationship between this, and also there's 3 layers. You can there's 2 ways of doing it. One is to extract the features from LiDARs. The other is to use the deep learning models to detect the tree canopies from aerial imageries. And all this is just kind of like part of the whole digital twin building process. If you have car layers, if you have roof layers, tree layers, if you combine all this with building, roads, all this thing, then it will form a really big sort of digital twins, and you have all the data sitting in the same place. So it gives you a better understanding of what sort of scenarios you are sitting in, and to help you to make decisions better. So we also have a lot of resources of where you can find sample notebooks, where you can get some blogs, so you can keep read the blogs, so you can keep up to date of the new coming pre-trained models. And also we can probably look at sharing some of our workflow and the result, the dashboard as well, if any of you is interested. There's documentations, YouTube's, there's a lot of videos and tutorials up there as well. I think this webinar will be recorded and published, uploaded to our YouTube channel as well. So, and there's also this demos page, which have a lot of good examples that can help you understand more about the AI capabilities in ArcGIS. So there's also upcoming webinars, which is the ArcGIS Agriculture Tech, and also WebGIS interconnecting your organization and migrating to ArcGIS Pro, which is coming in the next couple months. And I guess we've shown some of our works with cost detectings and car distribution comparisons today. But what we want to spend a bit of time is the Q&A, just to discuss some ideas. If you guys, if this our presentations, our demos spark some ideas in your heads, I think it would be good if we can discuss it, and we can discuss what sort of how we can help you guys, and also will it be possible to use Joe AI to achieve something that you're trying to do. So Q&A, and let me have a look in the chat. Do we have any questions in there? Okay. So from all the attendees, do you guys have any questions, any ideas that you want to discuss?
Yeah, hi Ed. Can you run the packages on imagery web services like NZ Imagery?
Yes, that's some things that we've been looking at. So We've been working with the content team, so to figure out a ways that we don't have to download the imageries, so we can just pull it from a service, and also how we can connect it to the Amazon S3 buckets, because Lens they are working on moving all their data to S3 buckets, and so that we can just connect it to the buckets, fetch the image straight away, and don't have to do the downloadings and image management. And also we are looking at how we can run detection tools on the base map. So for some object, you probably don't need area imageries with 7.5 centimeters. Say if you're trying to do land cover classifications, or if you're trying to find buildings, maybe it is possible to do it with satellite imagery. So that's kind of like the options that we are looking at the moment.
There's a second one there as well. I'm asking about deep learning tools in a disaster management.
Disaster management. Good one. Let me bring this up. So there's one that's quite popular in the States, which is the building damage. And there's also a parking spot detection model as well. Just not the related to disaster management. Just saw it and I realized that this is going to be related to the cars models. Building damage. It's definitely here. Maybe I searched the wrong name. Okay, let me have a look at the slides. I have it somewhere. Damage structures. Okay. Yeah, so this is the blocks that I'm trying to find, and the deep learning model. So it's doing the damage assessment using a deep learning and ArcGIS, and this is the workflows, the capture training samples, undamaged and damaged image. Probably don't have to go through all that. So basically, it will try to classify it and say this is a damaged building, this is undamaged, and what you can do from here is to find what's the sort of like impact assessment in the certain areas, and there's X amount of damaged buildings. What's the waste that you have to remove? How you're gonna plan for probably not the rescue, but how you can recover, and what's the cost for doing the process. And yeah, so this is it colors in two colors. One, the green color is the undamaged buildings, and the red colors is all the damaged buildings. So hopefully this is this answer your questions about disaster management. And we have talked to some people in the past about waste solutions estimation models after hazards. So if you guys have any specific use case that you're interested in, feel free to reach out and we can discuss how we can help you guys to train the models. Cool. The model should be here, but yeah, maybe I can try to find the models and send out an emails to all the attendees today later on. Is there other question, Andrew?
Yep. What other applications of deep learning and XR, such as virtual reality?
What are the applications of oh yeah, we should have shown that. So once you say doing the feature extractions, and then what we have done is we find the power cables and also the trees and the buildings, and once you have all these three things sitting in one scene, then you can create the VR 360 VR from there. And for your field workers, what they can do is they don't have to really go to the field. They can just sit in the office, and then they can just use the 360 VR to travel around to kind of like pretend that they're standing on top of the buildings and look at the trees and power cable, power poles, and plan their sort of workflows. Are they going to do the repairings from this direction or from other direction? I can probably look at bringing that 360 VR application up. So just bear with me. Yeah, so this is definitely a cool way of to show the results. So from 2D into 3Ds, and then put it into a scene. Then we go into a 360 VR. And it works really well in tablets. Maybe if you have a big phones with a big screens, then it will work pretty well. Okay, I have this. Okay, hopefully this is the right one, or I will try again. So from a scenes, you can export it to a VR experience, and then you get a 360, and you can open in ArcGIS 360 VR. So something like this, you can open it in the tablets. So with this, we are standing on one buildings, and you're looking at there's a lot of vegetation encroachment. That's something that we're trying to solve here, and we have reclassified those intersected points into different colors, and then it's kind of like helping them to plan their works, how they're going to approach these problems when they send their workers out. And you can also have this close views of this is the power pole, the blue color dots, and the yellow is the cable from this angle, and from here as well. And this is the power cable intersecting with the trees, and this is just the top part of it, the intersected areas. So this is right beside buildings, probably our residential areas. Yeah, so this is kind of like if you want to show the result in 360 VR, you can also do it as well. And to export this, you just have to go to your ArcGIS Online and open the web layers in the scenes, and in the bottom left, that will be a buttons for you to share it, export it, or convert it into this format. So yeah, good questions. Any other questions coming in?
No other questions at this stage.
Cool. I was just thinking maybe we can go through the some of the documentation to see how it actually works, instead of just how we can just use the models and give you a better understanding of what's the model is doing under the hood, or how we train the models. So if we go to this developer.arcgis.com and API for Pythons, and you can find the deep learnings, and say we want to look at pixel classifications, and you want to see this is the backbones semantic segmentations, how the models are able to classify and find out segment out the regions for the areas for this is a parcel, this is just grounds, this is water. You can have a bit of reads of this. It's just pretty cool. It's all fall under the GeoAI sort of categories. And change detections. Change detections, it shows you how the city changed. We actually thought about using this for our use case as well, but the scales that we are looking at, it's just different. This is just way bigger. And this root extractor, it's a pretty good model to find roads from imageries, and then it gives you this nice lines in the features. So we have the lens parcel layers, and we've been using that, but this could be something for like a new areas, or you want to do a comparison as well, how well the model performs compared to those data that we have ground truth. And there's a root crack model as well. Let me find this. Oh, and also it rings a bell about another sort of areas that we're looking at this year is to prepare mobile ready models. So you can put it into Survey123 and use a connector to connect the models from your portals to Survey123 forms. So you can use it to, say you want to detect a car, so you can technically you can connect it to your CCTV, and when they stream the videos back to the servers, and then you can just run the models to say do a car counts, to measures how many cars have passed by in the last 60 minutes. And for Survey123, the model is going to perform the segmentations or detections on the client side, which is the mobile phones or tablets. And it will more be like a processing of footage instead of all this area imageries that's captured from tops. So yeah, so that's some things that we've been working on. At hopefully it will be ready by end of this year. Yeah, I think we have gone through quite a lot of contents today, and this documentation page, it really have a lot of useful informations, and there's one that's for address feature points, and yeah, this is also another one, how we classified the point clouds, what's the model is doing. So it's not just trying to find the hikes, finding the XY positions, it's actually finding the patterns between each points. And this is how we classified the trees, the power cables, power poles, and it's really good reading. Yeah, so if we don't have any more questions, then we can probably end it here, so you guys have can have a bit more time for your lunch. Do you have anything to add in, Ashley?
No, nothing from me. Yeah, thanks for showing those resources. They're very helpful.
Cool. Maybe I will just let it in with on this page, on this slide I'm in. This is the sample notebook. I think I want to reiterate this because it will save you a lot of time figuring out all the syntax and how you can get started. So strongly recommend to look at the sample notebooks to get started. But if you guys got any questions, send Ashley or myself an emails or to our support teams. If you got any questions, just let us know and we will try to help. Or if you're interested in the results that we got from the car detections analysis and the analysis results, or even the dashboards, we can probably look at sharing it publicly and share with all of you. So yeah, thanks everyone for joining, and I also thank you Ashley for joining us today, and Andrew as well.